Hello and welcome to Additive Insight, the original additive manufacturing podcast, and your source for news, interviews and comment on the latest 3D printing and AM intelligence, brought to you by TCT Magazine. I'm your host Sam Davies, and today I'm joined by amsight CEO Tim Wischeropp. amsight spun out of Fraunhofer IAPT in 2023 and has since brought to market a software platform that is designed to support additive manufacturing users with quality management. Joining the Additive Insight podcast, Wischeropp explains the foundational research that led to the creation of the company, provides his definition for what quality management really is, and shares the key features of the software platform. He also details the impact amsight has had with existing customers and looks ahead to how the capabilities of the platform might evolve moving forward. If you like what you hear, don't forget to subscribe wherever you get your podcasts. You can also head over to tctmagazine.com to subscribe to the TCT membership platform and receive more Additive Insight via our print and digital offerings. Tim, welcome to the Additive Insight podcast. amsight spun out from Fraunhofer IAPT in 2023. Can you start by telling us about the foundational research that led to you and your team setting up the company, and I guess tell us about the challenge that you were trying to solve?
Yeah, thanks Sam for having me, and a great question. Maybe as a little bit background information, I personally started working in the additive manufacturing industry in 2012. So right at the start where the big hype about AM started, and worked on a lot of very interesting projects over the years in space, aviation, medical industry. We saw the great potential of additive manufacturing really applied there. But what was surprising is that even if you go to the most advanced shop floor, to contract manufacturer, we have this great technology, this digital technology. However, if it comes to quality management, almost all of them ended up working with Excel in the end. So for tracking the powder, for tracking the specimens result, a lot of times that is done in Excel. And it works fine if you have one or two machines. However, if you start actually scaling your production, that gets very, very inefficient. First of all, you have a lot of manual work to type in the data in the spreadsheets. That is prone to error. Many times you just have one guy who actually maintains the Excel macros, and that gets hard to maintain when you scale the production. And although you might have a lot of data, it's actually very hard to use because the data is not connected. If something goes wrong, the real nightmare starts, because you need to dig through all of the spreadsheets trying to find what might have been the root cause of that. And you can't also use the data to optimize the production, for example, with statistical process control efficiently. So usually an engineer will assemble data for weeks until you do your first analytics. And we saw that there's no software in the AM industry that actually does that. And from conventional software for other manufacturing technologies doesn't work for AM, especially when it comes to powder tracking and powder mixing. And therefore we thought, the industry needs a software such as amsight, and software that actually helps you to automate your data management, so that you get rid of the manual burden, that you have all the data in one place and not many different Excel spreadsheets where the data is connected and really fully traceable, and therefore can really easily use the data for doing root cause analysis or optimize your production, for example, by statistical process control.
Okay, so as we've established, the company was launched about 3 years ago now. So at the point at which you were kind of spinning out from Fraunhofer, what had you developed by then, and why did you consider that to be the right time to commercialize the technology?
Right. We founded, or we started the company actually on 1st of April 2023. So just had our third birthday, if you like to call it that way. Mm-hmm. We had developed a prototype of the software at Fraunhofer just to prove the concept and see if there's demand in the industry. We started working on the prototype probably at the time COVID actually started. and we got really good feedback from the industry about the prototype, and then did the spin-off in 2023. We rebuilt the software completely from scratch because obviously we learned a lot about how the software should look like and how we should build it, and then spent the first year just to rebuild the software, and then started with onboarding the first customers beginning of 2024. And I think now we have a very mature software that is actually proven to work and deliver value to our customers. Coming to the second question about the timing, I think it was a good timing because, I mean, we all see that the industry is shifting these days. Maybe the last decade there was a lot of prototyping, show parts on the fairs, fancy parts, but now the industry is shifting more into serial production, adding real values. There are a lot of really good parts that might not look as fancy but deliver actual value to the customers. And our software is really made for serial production, regulated industries such as space, semiconductor, aviation, medical, defense. And in all these industries, we see that there's a big growth, especially in the serial production part, and where we can add a lot of value for guaranteeing full traceability and actually making quality manageable for the customers in these industries.
Okay, and you founded the company with three others, I believe. There's a pretty significantly sized founding team. So can you tell us about the the collective experiences and skill sets of that team? What kind of what experiences are you bringing into amsight?
So we founded the company with four. So next to me, there's Peter, Raul, and Simon. Everybody, before you start building a company, you talk obviously to a lot of people, and everybody tells you that the right team is probably the most important ingredients for being successful. With Peter and Raul, I've worked at Fraunhofer for many years, and therefore we know each other very well from how we work and what the skill set was. So this is also why Peter takes care of our sales. He's a very communicative guy. I think has also learned a lot about sales at Fraunhofer before as the group leader. Raul as our CTO, or one of our CTOs, with the software development background, who also worked on building the prototype that we have done at Fraunhofer, so knew the technology, very passionate about additive manufacturing is also important. And me, I worked at Fraunhofer at a department lead, so there was a lot about strategy, financing topics, which obviously is also an important part for a company. And when we decided to do the spin-off, we thought that we would need another CTO with experience in building industrial-grade software, and Simon was a perfect fit. Peter actually knew him personally from his school time, and it was just a good timing for him to join the team because he was looking for a new job. Also moving to Hamburg at that time, and I think there were a lot of puzzle pieces that fit very well together. And since we're still around, doing a good job and getting good traction, I think the team works, and it's very great to work in the team.
Great stuff. We've touched a little on the amsight product that you've come to market with a few years ago. What does that product look like today, and I guess how does it work? What are the kind of key capabilities of that software?
So the software is a browser-based software, so you don't need to install anything on your computer. It can run in the cloud. It can also be installed on premise, especially for companies in defense, space, aviation. That can be a very key capability or requirement for such a software. And then you can just log in with your Microsoft account, for example. So very easy to deploy, very easy to access. And then the software has four main functions or capabilities, I would say. First of all, it helps you to automatically collect your quality relevant data. So Could be your powder data, your machine data by reading out the data directly from the machines or from log file, but also from post-processing or quality inspection. So yeah, a lot of the data that you already collect today, we collect in amsight, but automate that. Yeah, obviously there's a few things where automation is not working. For example, if you have a sieving station, or where automation is limited, I would say, have a sieving station or a manual mixing of your powder. For that, we have a special shop floor app that makes it very easy to enter data on the shop floor, where actually the powder handling or actual work happens. So yeah, we automate that. Then we have all the data in one place. So like I said before, for each part that you manufacture, for each build job that you manufacture in the software, with just one or two clicks, you have the full view of that part that has been printed with information about the powder history, the process parameters, quality inspection, post-processing, all of the data there with just one or two clicks. And now, because you have the data in one place, it's actually very easy to prove the quality of the part. So if you're a contract manufacturer, for example, you will have some kind of specification from your customer that tells you, okay, the part should have surface roughness lower than this, should have, if you do a 3D scanning, the distortion should be lower than this, and you print specimens, and the mechanical properties of the specimens that you print with the build job should be, elongation and break should be higher than 10%, for example, because you have the data and the specification in the software. You can show, I actually meet the quality requirements. You can also create a report for your customer with just a click. That alone can take several hours for an engineer today to do. And you can then also use the data to improve the process through statistical process control or do an easy root cause analysis.
Mm-hmm. And I guess the overriding thing about the software is quality management, right? It's addressing that with AM that for a while has been has maybe lacked repeatability and reliability, and has been working towards addressing that. And I've noticed on the company website and socials, you position this tool as kind of supplementary to things like MES and in situ monitoring. So I wanted to ask, how do you kind of define what quality management really is and what it looks like?
Yeah, great question. So when it comes to quality management, it obviously has different meanings depending on the person you talk to, and also different functions that it serves. From our perspective, you can differ quality management into three different layers. The first layer is the enterprise layer. So that is what a typical quality management system is made for. In such a system, you will find work instructions, order documents, standardization documents, things like that. Basically managing the overall quality management on the enterprise level. Then you have the lowest level, which is the system level. So the level of a single machine that actually monitors the quality of a machine. This could be sensor data of the machine. Obviously, from your OEM, from the machine manufacturer, you will already have software that actually takes care of the operation and quality of the operation of the machine itself. And there are other software solutions that help you to analyze these data in more detail, such as Interspectral, NebuMind, EditGuru, just to name a few, where you can actually use the data from one machine, analyze the data in high detail, and then get feedback on, okay, the quality of that build was good. Do I have some kind of anomalies? And we with amsight kind of sit between these two levels on the production level. So what we do is we take data from different machines, make these data comparable, and connect it to other data that is coming from the AM production chain. So powder data, post-processing data, quality inspection data. So we connect all of this data. So we operate on a similar level as a typical MES, so manufacturing execution software. And while the MES focuses on work orders and work orchestration, we complement these with quality management perspective and features typical MES lacks. For example, managing specifications, guaranteeing full traceability of parts, and the data analytics capabilities for root cause analysis or statistical process control for process optimization.
Some of the headline figures attached to your product, 100% traceability, 80% less manual effort, 100% data usability, they're obviously all impressive figures, but the one that I wanted to understand more about is the promise of less scrap, which I think you kind of project at up to 67% for users. So how does the software help to achieve that?
Again, great question. So when we take a look at typical errors that occur, you can differ them between so-called special cause errors or common cause errors. Special cause errors are things that are caused by specific and easy to identify errors. So typical examples of that would be the machine breaks down, or you used the wrong powder, or the part failed because support structures didn't really hold up to the residual stresses. These kind of errors you typically reduce by an enterprise QMS system, by standardization, by work instructions, by qualification of the machines. You try to, and the workers itself, you can really reduce these kind of errors. When we go into serial production, we barely see the special cause errors, because what you do a lot is the things I just mentioned. You standardize your process, you qualify your workers, you qualify your machines, and then you color code maybe your materials so that you don't put the wrong material in the wrong machine. So that barely happens in serial production. And what then gets more important are the common cause errors. And they seem to be random at first, and it's usually the root cause of that is hard to identify. So a typical example would be that you have a serial production of a medical implant or an aerospace part. Everything goes good for a few weeks, and then suddenly the mechanical properties are all out of specification, or the surface roughness is higher than usual, and you don't know where is this actually coming from. Is it the powder? Is something wrong with the machine? So that things get really complicated, and this is actually the kind of errors where we help customers to reduce them. Because the good thing is that, AM is a complex process, right? We have a lot of different, over 200 parameters that influence the quality of a single part, such as properties of the powder, oxygen content of the powder, over reuse that can increase. Obviously, the machine wears down, laser loses power over time, and summer it's 5 degrees hotter. And the problem is that once mechanical properties are off, you don't know which of these 200 parameters actually causing the root cause or causing this mechanical drift. And the good thing is that usually just a few of the parameters are overly important for the overall quality drift. And with our software, we help customers to identify them. So for correlation analysis, we can show, okay, fundamentally, the oxygen content of the powder is very important. So we need to make sure that the oxygen content of the powder should stay lower than 0.5%, or nesting density is very important, should be lower than 8%, and you should use an air conditioning to control the temperature or humidity in the manufacturing hall. And once you identify these key influence parameters and set quality gates for them, you can actually significantly reduce these common cause errors and stabilize your process and make it more reliable. And you mentioned 67% of lead scrap. That's an example. We have also customers that have higher rates than that, but this is actually where we come into place.
Okay. In terms of things like statistical process control, root cause analysis that you've touched on, can you kind of summarize the inputs that are needed for for that, and I guess the outputs. What do users receive, and what do they what can they visualize, and what can they see when they've inputted the whatever they need to input?
Yeah. Probably the best way to explain it is make a concrete example. So if we put ourselves in the shoes of a typical contract manufacturer that operates in a regulated industry, such as space, maybe. If he gets an order for a serial part, with that order, he will get a lot of specification. So telling the customer, okay, for the powder management, make sure that you only reuse the powder 10 times maybe. You need to print for each part 10 specimens, and mechanical properties or elongation of break should be higher than 10%. Tensile strength should be higher than 500 megapascal, for example, for all of the specimens that you manufacture. So what the software actually does is, first of all, you can visualize the quality of the parts over time. So actually, against the specification from your customer, show, okay, I am within specification over time, and is the quality going up over time, or is the quality going down over time? And if it goes down over time, you can immediately see, okay, it is now going time. Something, if I build 2-3 more build jobs, I'm probably out of specification. So what actually influences my quality? And then the software can help you to find, okay, what might be the root cause by, for example, doing correlation analysis and saying, okay, I have a good correlation between my powder reuse and the mechanical properties, or between my temperature in the manufacturing hall and the power the elongation at break, or I have a good correlation, or it's just one machine where it's going down, and then helping you to identify it's just one machine, then probably it might be the laser, it might be the filter on the machine, or if it's the whole production, the root cause probably is more on the powder management or operational side. And the software helps you to visualize the data and analyze the data. Furthermore, it also helps you to see how filter changes, maintenance activities influence the quality, and if you can optimize your maintenance activities on the machine.
Okay. I know that in terms of data, amsight sees fragmented data as one of the largest hidden costs in additive manufacturing. So from your experiences talking to customers, using the technology in the past, what is the scale of those costs for a typical business? How hard can that be for a user of additive manufacturing?
Yeah, it's definitely individual, and it's hard to say because almost nobody tracks the costs of fragmented data and hidden data, but they usually turn out in two ways. The first one is manual workload. We've done example studies with customers of ours to show that actually engineers in an AM team spend more than 30% of the time on data management tasks. So these are tasks such as typing in data in Excel spreadsheets, or assembling data for a customer report, or digging through data for a root cause analysis. And if you have a setup with 5 or 10 machines, you usually also have 5 or 10 engineers, and you can easily do the calculation in your hand, and you end up very easily in 6-digit numbers just on the data management tasks and manual work you have for the data management. The second one is if you don't have a proper data management and have the data scattered, the data is hard to analyze, and this is the reason why almost nobody does it. And especially, if you have you do scrap. For example, the example I just explained in the previous questions, you have serial production of a part, and at some point the mechanical properties are off. You will find that out in end of line. So when you test the specimens of the part, and then all the work has been done, and such a job easily costs 10 to 20,000 euros. And typically with a setup of 5 to 10 machines, you have a few of these build jobs in a year. And again, you can do the calculation and end up very easily in a 6-digit number just for the scrap part. And if you can reduce that, just by 50% and reduce the data management by, let's say just 50%, there's a lot of cost-saving potential for that.
You've told us what the software is and what it can do. In terms of implementation, how does an existing AM user, kind of take this software and implement it within an existing workflow?
Yeah, our philosophy, and this is also what we've learned over the years, is that it's actually hard to change current existing workflows. So we build the software in a very adaptable and configurable way so that it actually, our goal is to change the existing workflows as less as possible and try to customize the software in a way that that it meets the current workflows of our customers. So they don't really need to change their workflow, but a lot of what they do today will be done automized and save them a lot of work in the future. However, saying that, it's fair to say that amsight is not like a plug-and-play software because quite easy to understand. Once you have the customization and configuration, that takes some time. So I would say that probably after 6 to 8 weeks, you are really operational with the software. We are far away from being like an ERP or MES style integration project that takes several months or even years. But there's some kind of obviously learning the software, customization of the software until you're up and running.
Okay. And you've touched on it a little so far in terms of scrap rate, for example, but in terms of the impact that your software has already had with users, what have you helped some of your customers to achieve in the last few years?
A few KPIs you already have mentioned, such as scrap reduction of 67%, reducing of data management tasks, guaranteeing full traceability. And I think these are the key parameters that our customers actually achieve. And especially in regulated industries, where you have a lot of documentation and report creation, I think that we add a lot of values just helping customers to automate this task that takes several hours or days before into minutes. And the basis for that is always that amsight has all data in one place for all the use cases that I just mentioned.
And in terms of sectors and industries, which industries have been the most interested in your software so far, and I guess which do you see moving forward being suitable users of the software?
Industries with high quality requirements are the best fit for us. So regulated industries, obviously, I mean, everybody is doing defense these days. That is obviously very, very interesting for us as well, but also the industries, space, medical, semiconductor as well. We see that there's good traction as well. There's a lot, semiconductor industry in Europe, obviously. And we see the highest traction coming from contract manufacturers because they have the highest quality requirements in the industries, more than an an OEM. They also have the highest burden for reporting, for audits. And so that is like we see where the biggest traction is coming from, followed by OEMs with internal manufacturing capabilities. They also have obviously very high quality requirements, but usually less reporting that need to do because they are their own customers. However, saying that, we also have research teams that use amsight to structure or analyze their data for process and material development, for example, or doing machine qualification tasks.
Mm-hmm. And having originated in Fraunhofer IAPT, I'm sure you and then the rest of the team carry with you a passion for research. So in terms of product development, what are the kind of next challenges that the amsight is looking to address?
We want to make the software more intelligent, I would say. So maybe you can call it developing kind of a quality co-pilot for your production that continuously monitors and makes suggestions to improve your production. All of that is already possible today, but yeah, you have to do that on your own, let's say. And we see, especially with AI, that offers very good new opportunities to make that happen and more intelligent. Obviously, we always have to keep in mind that we mostly operate in very sensitive industries where data sovereignty and security is very fundamental, and we always have to keep that as a baseline when we talk about AI, using AI for our customers.
And finally, Tim, and thank you for your time today. What is your vision for the company moving forward?
Our vision is to establish amsight as #1 software for production level quality management in the industry. I think we already have a very good footprint here in Europe. We are currently focusing on expanding that throughout the year. Obviously, the US market is also very interesting for us, and it's probably focus for next year. We see a lot of opportunities and also need for the software such as amsight in the industry, and that will be the next step then for us in 2027.